Hi class, this is Mr. Pyrus. Now we're going to look at our second section of our test 20 review. So here's our next problem. It says, what is the area of this rectangle? Well, we all know that the area of a rectangle is equal to length times width. In which case we have let's go with our length is 2 times the square root of 2 times the square root of 2. So what do we do with that? We go and make it 2 times, we put the square root of 2, since they're both under radicals, under the square root radicals, we can do 2 times the square root of 2 times 2, which is equal to 2 times 2, or your answer is 4. So the area of your rectangle here is 4 square units. Okay, now let's look at this one. We're going to do this problem in a couple different ways. We have Becky thinking of two numbers. Their sum is 10 and their difference is 6. What are the two numbers? So let x represent the larger number, y represent the smaller number. Write two equations, one for each condition described, and then graph the equations and find the two numbers to solve the problem. So our first equation is x plus y equals 10. So what we're going to do first is we're going to say when x equals 0, y equals 10. And when y equals 0, x equals 10. And so what we're going to do now is we're going to graph this line. So when x is 0, y is 10. When y is 0, x is 10. So our next equation is going to be this. X plus y is 10, then x minus y is equal to 6. So what do we do with this? When x is equals 0, negative y equals 6, so y equals negative 6. And when y equals 0, then x obviously equals 6. So we end up graphing these guys, and what we can see is we have kind of sorta we're at 8, 2. We'll kind of agree with that. Okay, this is why I really don't like doing it by graphing, because it depends on how precise your graphing is. So let's look at this a couple of the ways. We're going to first do this by replacement, and then we'll do it by adding them together. Sorry for this 9, 10. So let's go and do this by replacement. Okay, the sum is 10, so we have x plus y equals 10. Okay, and their difference is 6. So x, y equals 6. So what we can do here is, in the case where we have the first, x plus y equals 10, we can go and we can say the y is equal to y equals 10 minus x. And so we'll replace that in here, and we have x minus the sum of 10 minus x is equal to 6. So then what we do is we put that together. Okay, so we have x minus 10, actually plus x. So we end up with 2x is equal to, and we subtract 10 from both sides, and we have, say, that's equal to 16. So x is equal to 8. So after we do that, we will put that back into our original equation where we have x plus y equals 10. But in this case, we said 8 is what x is equal to. So we have 8 plus y equals 10 equals 10. Sorry. And now what we got to do is we got to subtract 8 from both sides. We have y is equal to 2. So again, we come up with the same ordered pair, which is 8, 2. And that's what we ended up in the last one too, when we went and tried to graph it out and did as good as we could. So it's not as precise, but it works both ways. And I'm going to show you one more way to do this, and that's going to be, we first go and we take our first equation, and we're going to add the two equations together. So we have x plus y equals 10, and then we said x minus y, x plus y equals 10 equals 6. So we add these guys together and we end up 2x plus 0 equals 10 plus 16, 16. So therefore x is equal to 8. So we pick either one we want and we can put it back in, and we'll pick the x minus y equals 6. And what we're going to do here, if we have x minus y equals 6, x is 8, so we have 8 minus y equals 6. So we subtract 8 from both sides. We have negative y equals negative 2, or y is equal to 2. So you see there's 3 different ways that you can do that. There are other ways to do that, but we'll just concentrate on the 3 that we were talking about here, and you should be able to get that. Alright, let's move on to our next problem. Graph the number line. Negative 3 is less than or equal to x is less than 2. So first we go over to negative 3. We have it's less than or equal to. So therefore it's inclusive. And it does include the x, so we put on a solid dot on the negative 3. Okay, it's less than negative 2, so it's not inclusive of negative 2. So we have an open line on negative 2, and we'll just draw our line. Easy as pie. Okay, so when you have something like this, this is going to be the intersection of 2 equations. One is x is greater than or equal to negative 3, and x is less than 2. So in every situation when you have x greater than and less than, you're going to have this segment in between. So let's move on here. What 2 numbers are solutions to the equation? This one's fun. 3x squared plus 6 equals 81. So let's write it out. 3x squared plus 6 equals 81. And you all know what the first thing to do is. The first thing we do, we got to isolate the x. So the first thing we want to do is get rid of this bad boy. So we end up with 3x squared. And we subtract 6 from both sides. And we'll end up 3x squared equals 81 minus 6 is equal to 75. So 3x squared equals 75. So the next thing you want to do is divide both sides by 3. and you will end up with x squared equals 25. Having some internet problems in my house right now, so this doesn't always come across very well. So x squared is equal to 25. Okay, so x equals the square root of, okay, forget that, x is equal to the square root of 25, in which case it's equal to plus or minus 5, and those are your two solutions. And when you have a square root of a positive number, you're going to end up with positive and negative square roots. So here we have the square root of 25 is positive or negative 5. Okay, next one we got expand. X plus 3 times x plus 3. This is pretty easy. You know how to do this. We just FOIL this. Now keep in mind, when it says expand, it does not say solve for x. So do not try to solve for x. But here's all you do. So we end up first, x times x is x squared. Okay? Then we have outside, which is plus 3x. Then we have our inside, which is in the plus another 3x. And then we have last, which is plus 9. So the only things that we can combine here are the plus 3x and the plus 3x. That becomes plus 6x, so we end up with x squared plus 6x plus 9. And that is, oh by the way, what x plus 3, the quantity squared, is. So x squared plus 6x plus 9. Try not to make that any harder than it is. Whoa. Gave you that answer already. Okay. Set of integers is a subset of the set of. Is it a subset of the set of irrational numbers? Well, no, because irrational numbers are the square roots and things like that. So the set of integers is not a subset of irrational numbers. Is it a set of rational numbers? Yes, it is. Is it a set of whole numbers? No. Instead, whole numbers is a subset of integers, and counting numbers is also a subset of integers. Go by elimination. Go through them all. So obviously the answer here is B. All right. So here we go. Which of the following relationships is not proportional? Okay, the time worked and money earned at $12 an hour. Okay, so if you work 1 hour, you get $12. 2 hours, you get $24. So that goes through the origin. If you work no hours, you get 0 money. So that's a straight line, linear, and so you get $12 per hour. That is a proportional relationship. So that is not the answer to your problem. The side and the length of the perimeter of a square. Well, as sides increase, length increases, and it's a direct relationship. It's not one of those things because the length of the perimeter is just the sum of the sides. So if you double the sides, you double the perimeter. So that's going to be a proportional relationship. Time driving and distance traveled at 45 miles per hour. So if you drive 1 hour, you go 45 miles. You drive 2 hours, you go 90 miles. If you drive 0 hours, you go no. So again, we're going through the origin. So that leaves us with the side and length of the area of a square, and that is not proportional because as your sides increase, your area increases by the square of the increase. So if you double the sides, the area becomes 4 times the size. If you triple the size, the area becomes 9 times the size. So the obvious answer here is D. Now keep in mind, since you have B, the side and length of the perimeter of a square, and the side and length of the areas of a square, you really can narrow down. It's got to be one of those guys. So think this one through and don't be afraid of it. And we're going to stop here for this segment of the Test 20 review, and we'll come back in a little bit with segment 3.